Good afternoon and welcome everybody to the ENS webinar series. Today about nuclear new build and the question if we repeat historic mistakes during those projects which we could have learned from the past. I'm happy to welcome Jan Blomgren from INBex in Sweden as our speaker and presenter today. My name is Helge Gottschling from ENS. The webinar is divided into two parts. First, we will hear the presentation by Jan, and afterwards you will have the opportunity to raise your questions. Please make use of the opportunity to also type them in during the presentation. You can use the software tool to directly type your questions. I will collect them and forward them after the presentation and directly address to Janne. He will be able to answer, and by that we can have a viable dialogue together with the speaker. That's everything from my side. I would like to introduce you, Janne, and the floor is yours. Thank you very much.
Thank you, ladies and gentlemen. As was said, my name is Jan Blomgren. I'm president of the INBex Corporation, and today I'm gonna present some studies on historic mistakes and successes as well in new build back in time, and see what we can learn from them today. The material has been worked out by myself and my colleague Nils-Olof Jonsson. First, a quick introduction to my company. Our name is INBex, stands for Institute for Nuclear Business Excellence. We're a small consultancy rooted in Sweden and Finland, but works all over the world. We provide consultancy, independent advice, lots of training of executives and close to executive level, and we love to work for emerging nuclear countries, primarily in Africa for the moment. We are about 25 people, a network. This is a modern company, no permanent staff, no office, and no SAP system. Most of our team has prior experience as being a CEO, Director General, or similar. So if any one of you becomes president of Vattenfall or EDF or whatever, and you would like to train yourselves not to make a core meltdown unnecessarily, just contact me. So, to the topic. This is based on a study which was performed by myself and Nils-Olof Jonsson about how nuclear new build was performed in Western Europe and USA during 1970 to 1990. And see what was done then, what of that is useful in new build today, and what is not. I can remind you, we had the situation that we have a bonanza of nuclear new build in the Western world up till about 1990, whereas the coming 20 years thereafter was standstill in most of Europe and all North America. We've seen some new build after 2010, USA, Finland, France, but far from the volumes that were there in the 70s and 80s. UK has ambitious plans, but so far we haven't seen much dirt being moving around. Whereas other parts of the world, Russia, they have been going on, Japan, Korea, China has built with a steady pace more or less since 1980 and so on. But this study focuses on Western Europe plus North America. So we don't include the experiences from these mentioned countries. Next one, please. Well, the first thing you have to realize is that the world is different now. The maturity of the technology is very different. When we started building nuclear power in North America and Western Europe once upon a time in the 60s and so on, nuclear power as a technology didn't exist. We had to invent it first. There was a large need for research and development. Constructing research reactors was an important matter simply because we didn't have any full-scale power reactors, and building smaller ones in the few 10 megawatt scale and so on was a reasonable activity at that time. One thing we often tend to forget is that nuclear power at that time was cutting-edge technological research. The bright young students coming out from university, they went to nuclear power because it was really the sexy technology, together with the space that was coming up at about the same time. I've included a picture there of a bomb plane the US developed that should actually have been reactor propelled. They were actually flying around, the reactors going critical, in total 83 hours, I seem to remember, although the reactor didn't propel that particular plane. So at that time, everything was possible. People tried everything. It was really the cutting edge technology at that time. The situation is different now. Today, you buy nuclear power plants off the shelf, quote unquote. Yeah, it doesn't really work like that, but you have a number of suppliers that have existing technologies. They built them before, and so on. We have half a century of experience in operation and so on. So the technology is much more mature. I sometimes meet people that ask newcomer countries or suggest that they should start by building a research reactor, and I tell them it's the wrong way to go, because the fact that we did that in 1950, 1960 was not because it's the best way to learn the technology today, but because it was the best way then, when nuclear power as an industry didn't exist. Today, when you have 400 operating nuclear power plants in the world, if you want to introduce nuclear power to a new country, the best way is to join in with the others. Send people to participate in operation at existing nuclear power plants all over the world and start building. Going through a new R&D phase of what has already been performed doesn't make the same sense. And today, nuclear power is not the research frontier. I take the risk now that somebody might roll me in tar and feather, but we have now come to the situation that 50 years back in time, nuclear power was a fast developing technology with lots of experiments. People tried everything, and today we're in the situation that it is a mature technology producing electricity, and it's about the most conservative technological businesses you can see. It takes forever to introduce new technology into nuclear power, and we today have a reputation of an industry that isn't very fond of introducing new ideas. And to some extent, I'm afraid that scares off young people to go into the business. So the situation is completely different now than it was then. And if you haven't made that clear, you might repeat previous things that were not mistakes back in time, but would be mistakes if you repeated them today. Next one, please. Helge, thank you. If we now start to look at plant construction and safety, first of all, many things are very similar today. First of all, when it comes to plant construction, it's basically the same thinking. We have seen evolution, not revolution. The main components are the same, the sizes and so on are pretty much the same. I like to point out that the first electricity producing reactor, the EBR-1 in Idaho, lighting up the 4 light bulbs you saw in the previous slide, that went critical in 1951. A few years later, we had reactors of about 50 megawatt electric. 1971, we had the first reactor above 1,000. That was Zion in Illinois. That was also in the previous slide. So in a 20-year period, we went from essentially nothing to over 1 gigawatt. 1,100 megawatt electric, that's pretty close to what you see commercially today. The Russian VVER reactors are typically 1,200. So in the range 1,000 up to 1,600 or so, that is today the range. And that has been the range now almost half a century. So plants are fairly similar when it comes to the sizes and the base construction. That's also true when it comes to safety requirements. It's basically the same thinking. It hasn't been any revolutions there, but there has been evolution. What is different now is that plants are larger than back in time, but not dramatically larger. when it comes to power, but they are larger when it comes to footprint. If you look on a map, the physical size of them, they are dramatically larger today than they were at that time. Partly it's because we do have more safety systems, we have increased redundancy. To some extent, we have made them more complicated. If you have 4 subsystems instead of 2 subsystems, it often requires more land and so on. But as I said, this is not a philosophical difference, I would say. It's minor differences. On the safety side, what we can see is that we have got more defense in depth. When the first nuclear power plants were constructed, we were fairly similar to the safety requirements as of today, but we have made them sharper over the years. We have got more emphasis on core meltdowns, which was considered very unlikely when nuclear power was taken into operation, although people at that time, they also saw a risk for it, but it was not as high up on the agenda as it is today, I would say. And now we have experienced 4 core meltdowns in light water reactors, and we've had a major explosion in a graphite reactor. We have seen an increased volume of paperwork, and it's a dramatic increase when it comes to administration, verification, and so on in this business. Just as an example, I can tell you that when the first commercial nuclear power plant was taken into operation in Sweden, in the licensing of it, at that time it was enough to call the largest hospital with cancer treatments in Sweden, because they were in charge of radiological licensing. So the radiological licensing was a phone call to a bunch of medical doctors. I exaggerate a little bit, admittedly, but it's a complete difference there compared to what the licensing procedure looks like today. One important difference I would like to stress is that today you need a broader understanding. At that time, in the 60s, 70s, this was seen primarily as a technological challenge, whereas today we have realized that the human factor, organizational factors, and especially their combination must be taken into account. We cannot understand the challenges to nuclear power safety by seeing this as a technological issue only. When I talk with young people, for them it's completely self-evident. When I talk with the recently retired people, they tell me that this has really been a big change over the years. So that has changed their perception over the years in this industry. Next slide, please. So when it comes to technology, it's not a dramatic difference, I would say. Things have improved, but it's not a revolution. On the market side, there has been much more changes, much more dramatic changes. So the economic landscape has changed much more than the technical one. When this started, all over the world, electricity production was a regulated business. In essentially all Western countries, we can forget about the communist countries for the moment, but in all the Western countries, the normal state of operation was that the government was responsible for having electricity in those 2 holes in the wall. In some cases, the government operated the whole thing themselves. In most cases, you had private companies that operated under government surveillance and license and so on, which meant that the government said that, okay, we need this much electricity, and you should produce it, and you're allowed to make a reasonable profit, typically in the 10% range or something like that. And this results in a price to the consumer, which is this much. But it was a regulated activity. There we see a difference. From the mid-90s and until today, a large number of countries have deregulated electricity generation, power production. Mine is a good example. We were among the first ones. So we have had unregulated markets since 1995. That means today the operator of a nuclear power plant does not know the revenue more than in a short time period. That is, prices are set daily, but you can secure a certain sales price a year or two or a few years at most, but hardly beyond 5 years. Whereas previously you could more or less make a calculation for the rest of the life of the plant. You knew that you would get a reasonable income, not fantastic big, but pretty safe for the whole lifetime of the plant. And that also means today, typically you have little or no subsidies or supports to nuclear power simply because it's mature technology. Whereas when it was started and it was a new technology, there were incentives to get it onto the market. So that's a major change on the financial side. I wouldn't say nuclear power is less profitable today, but it's more uncertain profit. It's much more difficult to predict what your future income will be. But we have seen in the last 15 years or so, periods where nuclear power has made essentially no profit at all or even loss because of low sales prices. But we've also seen periods where they have made huge profits because of high prices on the market. And here we can see that the sales price of electricity is by far the dominating factor. Nuclear power has the problem that we have essentially no variable costs. If we stop producing, we have essentially the same costs anyway. It costs the same to pay the mortgage on the plant. We can't lay off people just because we don't produce. We have to have the same number of people on board. We can't even save on the fuel more than marginally by stopping production or taking down the production. So for us, full speed operation and high electricity price, that is what's needed for us to make profit. Next difference is that the world has become international. When nuclear power was built in the Western world, it was domestic markets essentially and domestic suppliers. In Germany, Siemens built most of the reactors. In Sweden, ASEA. In the US, Westinghouse, Combustion Engineering, etc. In France, EDF, Framatome. The major suppliers, they were national. They built for their own country and maybe some neighboring countries. Sweden exported to Finland, France exported to Belgium, etc., etc. Today, the picture is different. We have an international market. We have global suppliers. The suppliers today, they build plants essentially all over the world, if they build at all, that is. Next difference is that back in time, we had companies that had capacity to supply essentially everything. I can take Sweden as an example. We had what was then ASEA, today part of ABB. They built the reactors, they built turbines, they built generators, they built the electric switchboard, they built the control INC systems, etc., etc. So when you went around the plant, it was the same logo on essentially all the technical gadgets you could find. In Germany, it said Siemens on everything, etc., etc. This was for the supplier a good situation because it meant that if you got problems in one area, you could gain back in other areas. You have to remember that many nuclear power people, me included, have a large focus on reactors, but a reactor is typically a quarter of a nuclear power plant when it comes to importance and cost. Whereas the turbine is an equally expensive thing, the generator is an equally expensive thing, and then all the houses, everything around it is about the same. So having somebody that supplied it all meant that if they made a bad deal on the reactor, they could partly recover it on the turbine and on the generator and so on. And for the client, it was good. It was a one phone call problem. When the Swedish buyer, Vattenfall at that time, were unhappy with things, they left the phone and called the CEO of ASEA at that time, which delivered everything, and they could sort things out fairly easily. And there was a similar situation in other countries as well. Today, we have complicated supply chains. There are literally thousands of companies involved in a construction project, and they come from all over the world. And even within each company, you have a huge internationalization. If you contact a company to deliver the generator, although the company officially is French or German or Swedish or American, the parts of the generator might be produced in Bangladesh and other places as well in a complicated chain. So it's more messy today, and few companies can deliver all of it by their own production. What they do is that typically the one that supplies the reactor then writes contracts with a supplier of the turbine and of the generator, balance of plant, etc., etc. But they themselves don't deliver more than 25-30% of the whole project. And that's a different situation to whether you supply essentially 100% of a project. Going back in time, there were a long series of projects. And that meant you had time to build competence. We can see that. I'm going to show you some examples later on that over time, the manufacturers, the suppliers, they learned how to build, and the future operator learned how to put demands and how to take things into operation in a clever way. They started to understand each other. The regulators started to understand the actors and so on. So the construction time went down, and the uncertainty in the construction went down thanks to long series. We can see that in my country, but it's the same essentially all over the world, that the first projects often got huge delays and they got cost overruns that were heavy. But the fact that you built 10 plants in a row, started a new construction every year or every 2 years for many years, meant that when you have made the first childhood mistakes on the first 1 or 2, then things went much smoother. Other suppliers were well trained at that time simply because you had a long series of projects. Today we have a different situation. Projects are short and uncertain. Often a supplier gets a contract on building 1 or 2 reactors in a new country they haven't been before, and they don't know that they can go on and build unit 3, 4, 5, 6, 7, 8, etc., etc. And we can see that suppliers aren't trained to the extent today that they were 50 years back in time, simply because of lack of chances to train. Finally, we can see that back in time, other domestic industry was quickly involved. Non-nuclear industry, but of importance to build a nuclear power plant, were quickly introduced into the system. Especially, I would take the examples of forgeries, building reactor pressure vessels, and so on. What has happened since 1970 and on is that USA and Europe has partly been deindustrialized when it comes to heavy manufacturing industry. You don't have companies today in this part of the world that can produce a reactor pressure vessel. Today you have to ask Japan Steelworks or companies in other parts of the world. We have lost that capability. I'm not saying that's necessarily bad. They do a good job. But you see a difference. Previously, it was people that spoke your own language and they were 100 kilometers away and so on. Now you have to get the things from the other side of the planet, and that increases the probability for mistakes. So to summarize, market has changed a lot, although technology has not. Next one, please. Now comes a difficult matter. For me, coming from natural science, I'm a physicist by training, and I love to look at laws of nature and engineering. But when it comes to failure in large technology projects, technology is not the main culprit when things go wrong. Take these numbers with a pinch of salt, but they are rounded off numbers. About 15% of all major projects that fail do it because of a mistake in the technology. About 15% project management issues, 20% other stuff, and 50% culture and communication. In short, people misunderstand each other. And you can probably, I'm not going to point out specific projects that have gone down in the nuclear sector recently. I leave that to the audience. But take a look of the projects that have been severely delayed and have large budget overruns, and think about which of these factors do you believe is the most important one. The ones I know about, all of them are culture and communication. People have invested in the technology, but they haven't invested to the same extent on understanding each other. If you're a country in Europe and you buy a nuclear power plant from an Asian supplier, for instance, I take that as an example because it hasn't happened yet, but it might happen. Do you understand what they mean when they say this is safe and so on? I don't think that we invest enough in understanding the unknown, the unwritten messages, the unspoken things. So understanding each other, understanding values, what do people really mean when they say something? Do they speak the truth, etc., etc.? That's something we need to focus more on. This is not a uniquely nuclear thing at all. You see the same thing in other areas where you have international business. However, I think other industries have solved this better than we have. For instance, in the oil industry, where you often have people from all over the world working together, they have structures to overcome the culture barriers that we have not developed to the same extent in the nuclear world. I have a few burning bullets further down on this page, and this is primarily towards new nuclear countries. So those of you being in Western Europe and US, some of this is true, but maybe not the first one. When we look at new countries, now we're talking countries in Asia and Africa primarily, my number one bullet of what can go wrong is corruption. If you try to build a nuclear power plant in a country where you can get a certificate that the pressure vessel is correctly tested, if you put sufficiently large amount of money under the table and the test was never carried out or not in the right way, you have a problem. And that's a risk we can see in essentially all the emerging nuclear power countries. There's a logic in it. Countries with low levels of corruption are the ones that have developed. They are technically and economically developed. Corruption is the number one reason that countries have not developed. So the countries now that embark on nuclear power are the ones that need to develop. That is, they are undeveloped because of corruption to a large extent. And this is a really difficult message to give to energy ministers in Africa and Asia, telling them that the fact that you haven't managed is corruption. And that is the biggest reason why this huge project you want to carry out might go wrong. Work on it. Especially if you look that person into the eyes and you know you're talking with a corrupt person. The other areas, miscommunication in the licensing, that attributes to what I said about culture and communication. And finally, unclear roles and responsibilities. That is something that you learn over time, but it's in the first project, you often see it in most countries. Now we move to the next one. I would actually jump the first one. That's sufficiently well known in the Western world. That's more for newcomer countries. We go to the second area, delays and cost increase. Oh, thank you. How do you avoid delays and cost increase? One suggestion there, but I'm willing to say that you don't solve all the problems, but look at it this way at least. Have a main contractor, primarily the one that supplies the nuclear island, that they should supply large and critical parts. If you have a company that takes responsibility for the whole project, but they are not heavily involved themselves in producing large and critical and expensive parts, it's difficult to get the right feeling of responsibility for the whole thing. Make one company responsible for the full supply chain. That's important. If you try to buy about the same amount from 4 or 5 different suppliers, none of them really puts this at the top of their agenda because they have other clients too. And try to find solutions where all parties win together or all of you lose together. Strive for win-win situations in the first case, in second case lose-lose situations. If you have a situation that one party is trying to win at the expense of the other, you are pretty certain that you will end up in difficulties. We have seen delays because of licensing. I realize that the medicine we suggest is not an easy one, and that is develop your own criteria, which is stricter than the regulators already before you start, so that the regulator will be impressed along the way instead of being grumpy with what you're doing. And make sure that you communicate well with the regulator all along, already from the start. Spend time on being together with the regulator, communicating with them to understand their thinking, make sure they understand how you are thinking, build confidence that they believe that you know what you're doing. If you haven't done that, I'm pretty certain that you can see problems later on, or at least our findings seem to indicate that very clearly. Let's move on. And I think we can actually jump this page, Helge. Let's go to page 11 instead, because this was just a summary of what we just said. I'm going to show you some data. The construction time historically in 4 different countries. If we start in the upper left corner, we see Korea. Started off with 5 to 6 years construction time, but then it was when we are around 2004, 2005, we're down to 4 years. Korea is a nice example because they embarked on a journey where they built 20 units on a more or less conveyor belt schedule, starting a new project every year, finishing a new project every year, and typically on time and budget. And you can see the time started off around 5, but it was creeping down close to 4 over the end. Then you can see a spike in the end, still not dramatic, it's 6 years, and that's a delay primarily for political reasons. But in the Korea, you had the situation, it was a Korean manufacturer, a Korean regulator, and a Korean buyer/operator. And over time, they understand how the others were working, so the system was well oiled, was well lubricated. If we go to France, we see a similar situation, that at first we had around 6 years for the project, which was slightly creeping down from the early 70s and to the late 70s. But then things started to creep up again, partly because of taking new technology into operation. So they had a technology shift. Then things jumped up when you learned that. You had at least one bad example there, which produced a huge spike, 12 years. This big bulb going up to about 10 years in late 80s, we have got different explanations of it. When I've shown this in France, the explanation has been that they had realized that they had so many projects running at the same time and had a shortage of human capacity to perform it, and also industrial capacity, that they deliberately decided to stretch out the projects instead of rushing them through. So the other message is that this was semi-planned, so to say. It was an adaptation to reality. I've heard other explanations from other people, but I won't tell them here. let's jump Germany. Let's look at the USA. USA has an interesting trend. The time went up, and it was always almost twice the estimated time for a project. In the US, they had a licensing procedure, which, with a slight exaggeration, can be said that first you get permission to build a nuclear power plant, and then when you're done, then you get license to start operation of it. That's true all over the world, but it seems like the procedures for getting permission to start construction was not that dramatically difficult in the US, whereas the procedures to allow operation were much more stringent. And therefore, you sometimes run into problems that when the whole plant was more or less complete, you had to rebuild it to fulfill the criteria for starting the operation. So that could serve as an argument for develop your own tougher than the regulator criteria already from the start to avoid delays of that time. In the case of the US, at least at the end of this period, you also have the situation that the oil crisis in '73 that curbed the demand for electricity, and therefore it wasn't such pressing need any longer to rush a large number of projects through. However, you can see that it goes the other way around. After the oil crisis, the construction times went down, which probably is because many of the beginners' mistakes had already been made, and people were more competent at the end of this period. I don't have nice data for Sweden as graphs, but I can tell you that the situation is pretty much similar to Korea. The first nuclear projects in Sweden, they were not, they overran their budgets and the times, the first 1, 2, 3 reactors. But then we were in the situation, we built 12 units over 13 years. And the last half, there they kept time and budget, and it was 4 years from pouring first safety rated concrete to power to grid. So that plants were built actually faster in those years than they are today. Next one. Let's go to the bottom immediately, because we have seen the upper half is most a summary of what we already said. One thing I think we need to take a look at is the information overload. At the bottom, you can see the number of new regulatory requirements, and these are Swedish data. Look at the numbers. When we've come into the 80s, we were in the situation that there were 150 new requirements per year. And I mean, this is on top of the already existing ones. So this is every 2 work days, there is a new regulatory requirement to take into account. This is, of course, extremely difficult for the poor operator to take this into account, and for the supplier as well, when the demands change so fast. All of them should be implemented in your work and so on. Some of them might be easy, but still, just knowing all the new requirements that are coming is a difficult matter. And this situation has not changed much since. It's a slightly lower pace today, but not dramatically lower. And this is something which is close to unique to nuclear power. There's essentially only one other industry that has a similar situation, and that is development of medical drugs. They also have a fantastic overload and burden of regulatory requirements to cope with. Next slide, please. When it comes to mistakes in construction today, we have a more complex design in many ways than we had back in time, with more redundancy and so on. I'm not saying it's bad, but I'm saying it makes life difficult to get all of it to fit and work together. We think there is room for improvement when it comes to modularization. In some areas we see too little, and in some others we see too much modularization. Being able to build complete modules off-site and transport to site and put it in, that helps a lot when it comes to avoiding construction mistakes, if you do it in the right way. But that's not as big problem as the licensing overruns, I would say. If you look internationally, you have more overruns because of licensing difficulties than of clear construction mistakes. It's notable that the requirements to operate nuclear power are fairly similar worldwide, but they are not officially recognized as such. Officially, they are national. So the requirements in France, Germany, Belgium, UK, Sweden, Finland, etc. So all of them are national, although they are similar. But that means that if you take a French unit and try to build it in Sweden, you must make technological changes. And those changes, in most cases, they don't improve safety, but they change the plant to adapt to the national requirements of the receiving country. Few regulators acknowledge this and see this as a problem, and few regulators learn from others. Well, they have some groups where they talk with each other now and then, and you have WENRA and similar organization for harmonization and so on, but we are very far from international standards in nuclear power. I used to compare with aviation. If you land a Boeing in the US, you can land it in Canada, France, UK, you can land it in any country. In aviation, we have international recognition of standards, but we don't have it in nuclear power, and that drives costs heavily. However, we find it unlikely that this will happen in the near future. We can see that this is a political thing. Few politicians in the world would like to give up their national sovereignty and say that, okay, we adapt to the rest of the world and let somebody else say what is safe with our reactors. That's okay in aviation, but not in nuclear power for some reason. Next one, please. But we have new challenges. Up to now, we have seen traditional challenges, but here we have the new challenges. The first one which should be mentioned is the globalized supply chain. How do we solve that? Well, the best recipe we can think about is standardization. If we can build identical units, make them same all over the world. If you build an AP1000 in China or in the US, build them the same as much as can be done, because then at least you can use the learning from one country to the next country. The multinational nature of projects, there we have to learn from other industries. Aviation and oil are good examples of industries which are very multinational and have got it to work in spite of having multicultural environments. Now we come to a really burning topic. This is not very popular to say, so now I'm going to say it. The fact that we have so few new build projects makes it impossible to have so many suppliers as we have in the world today. We have essentially 10 different industry consortia that can deliver nuclear power plants, or claim that they can deliver at least. But with the total number of projects in the world, that's too little to get this type of conveyor belt structure, long series where you can actually learn from, develop your competence, develop your supply chain companies, and so on. We would need a market consolidation. That means fewer suppliers. If we make a quick back of the envelope calculation and we compare to other areas, now we take aviation as an example again. There are 2 companies in the world that provide large jets for passenger flights, Boeing and Airbus, and a few countries that deliver smaller ones. But in industries where you have enormous investments and a global base, you often see 2 or 3 major companies does the whole thing. My guess is that 3 suppliers of nuclear power plants in the world should be reasonable in a situation where this would be a market thing only. So if we would stop national pride, we should stop letting governments support their national supplier, etc., etc., and allow this to be solved completely by the market. My prediction is that 10 to 15 years later, we would have 3 suppliers in the world, 3 major groups. That's about as much as you can take with the number of projects we have in the world. And that would provide a stronger cost base for new technology. Part of the reason we are not very good in nuclear power in implementing new technology is that we don't have financial resources for it. We have so many suppliers, and none of them has so many projects that they can make a good profit. That means they don't get the economic situation that they can invest in trying out new technology and taking the loss in the first 1 or 2 projects to implement it and then harvest from that investment. But how to solve this problem, I have no idea. And we can see that essentially all the suppliers in the world, they have some kind of government backup, and it's considered a national pride or a national interest to have this company around. So I'm pretty pessimistic about a solution of this problem. Next slide, please. Well, this more or less summarized the whole thing, and this is more advice for newcomer countries, Africa, Asia, and so on. This is not relevant to the same extent for companies in countries that already have nuclear power. So I suggest we save time and instead open the possibilities for questions. So Helge, if you bring up the next slide, there you can just see my email and web. So now you know where to send your email questions after this webinar. Helge, over to you.
Yes, thank you very much for that impressive presentation. Indeed, there were some questions, and I just directly start pointing them. And one came from probably Finland, and it was a bit stressing your idea of that you said very much in the beginning that today nuclear is a mature technology. And the colleague said, like, due to the fact that many of the components and many of the technology from those days, from the past decades, are no longer allowed to be used today due to regulators' demands to use state-of-the-art and technology. Many proven and mature technologies are not allowed to be reused or rebuilt when they reach their lifetime, so to say. And that makes technology not mature and even more complex.
Yeah, let me comment on that. I fully agree. We see that in many places, but in addition, it's not only a matter of the regulator and their demands for best available technology. We also have the situation that in some areas, old technology is better than the new ones. And in one area, it's instrumentation and control. When nuclear power was built in the 70s, we used relays. That's a Stone Age technology, we think, today. But it has the advantage that you can understand exactly what the system does. You can derive all the final states depending on the input and so on. Whereas today with electronics, nobody knows what happens in a CPU. A CPU is so complex that you cannot even in principle test all its outputs, and you cannot even in principle compute theoretically all the outputs for a given set of inputs. You have to make statistical tests and hope that you haven't missed something. So today, thanks to computers, you have an intrinsic uncertainty. Will this work in every conceivable situation? And there is no way around this, because this problem cannot be solved even in theory. But here we have the situation that today it's easy to buy electronics, but finding relays is not that easy. And secondly, the people that work with it, everybody's using a computer daily, but very few people work with the relays daily. So it's also a matter of whether we have people that understand the technology.
Yeah, thank you for that. Then a question was regarding your point, the market situation that you pointed on, and the issue of having insecurity of price forecast. Do you think we need more regulation to help to support nuclear?
Now I should give. I have to admit, I'm a big fan of markets. I think I would rather say the other way around. The problem is not that we have a market and that we have a market uncertainty. The problem is that we officially have a market, but then the market is partly interfered with, especially by politicians. They put subsidies on technologies they happen to like for the moment, and so on, and that makes it a distorted market, and that's more of a problem. If we were in the situation that we knew that there would be market prices only, and we knew the rules for the coming 20 years, we could take that into account. We could say that, okay, 2 bad years, but we make more money year 3 to 5, etc., etc. We could handle it, but we're in a situation that the competitors might get the losses paid anyway. Now you have a problem.
Okay. Good, thanks for that. Another question was touching upon communication and the cultural aspect that you mentioned when it comes to the source of problems or well, let's say problems during new build projects. The nuclear industry, normally in operation, seems to be one of the best connected ones due to WANO and all those international organizations that make exchange between operators possible. Do you think something would be possible for new build suppliers or vendors, or could it be solved by your proposal to reduce simply the number of the vendors by the market?
Well, reducing the number of vendors, I wouldn't call that a proposal. I noticed that if there were no national pride and subsidies involved, I think that would happen, but I don't think that will happen. When it comes to some kind of exchange between the suppliers, it's more difficult, because when it comes to operation, an operator in Europe is not affected of what an operator in the US does, or vice versa, in a positive way. That means if we learn from them, it doesn't harm their profitability and vice versa. But we are connected negatively. A core meltdown in Japan is a core meltdown in Germany. So there we're sitting in the same boat. We have a strong incentive in at least removing the major accidents together. And you have the same situation in aviation on that one. But on the supplier side, it's not equally obvious what you as a supplier would gain by giving away your crown jewels to your competitor. So I would think it would be much more difficult to have this type of exchange on the supplier side.
Good, thanks for that. Then you mentioned modularity as well as standardization. The things that or the thing that comes into mind is SMR. Is that an answer to many of the questions? So the technology of small and modular reactors, an answer to many of the questions you arose?
I have to admit that basically I'm a physicist by training. The physicist in me loves small modular reactors, whereas the business person in me is more skeptical. Economy of scale is a very strong factor in nuclear power. So building a 1200 megawatt unit doesn't cost 4 times building it costs less than building 4 300 megawatt units. I think that politics is needed to make that difference smaller, because there are many good physics reasons why smaller reactors would be great. But as long as we claim the same licensing level for smaller units as for large units, the licensing cost is a tremendous burden. The licensing cost for building a huge nuclear power plant, it could be 20-30% of the total budget. And if you now build smaller ones and you have the same licensing cost, I mean, the licensing cost could eat the profit for decades for a small unit. So we need a much more simplified licensing procedure for modular reactors to make them economically viable. I would strongly advocate such a thing, but unfortunately, I'm not a politician.
Unfortunately not. Thank you for that. Good. I think we're almost pretty much at the end. This was a good scheduled one. Thank everybody for having joined today. Thank you, Janne, for having been the presenter. Thanks for the impressive presentation. The documentary of this will be available to all attendees, but also to the absentees. Please also know this is a series. This was the first webinar in 2019, and more will follow during the year. Follow us on our website, and you will also receive additional information from your national network. So be there in February, and when it's the next time ENS webinar for you and from us. So thank you for today, and have a good day so far.